Hi everyone, today we from class DMI section 1 will be presenting the assessment task given for the Thermo-Fluids subject, which is called DMID1843, and the topic given is external flow. Alright, what we'll be discussing for this topic. So before that, let me introduce my group member first. As a leader, I am Muhammad Syahmi bin Muhammad Saiful Islam. Metric number is D12510032. Alright, for the next is Nurul Alia Akilah binti Nurul Syahrul Nizam. Metric number is D12510322. Nur Aisyah Amani binti Abdul Rahim. Metric number is D12510342. And Sofia Zahra binti Hanafi. Metric number is D12510326. And the last one is Gan Xiao Si, D12510051. Alright, so I will take the present for introduction. The first one is fundamental of external flow. For the definition is the behavior of a fluid, which is air, flowing entirely around the outer boundary of moving solid object. Alright, and for the engineering impact, which is a crucial minimizing aerodynamic drags, extending electric visual, which is what we call the EV, so battery rash, and suppressing high speed whine noise. Alright, so for the next is application and product profile. For the type of application, which is aerodynamic, which is external fluid dynamics. Alright, so for the product name, we choose the Tesla Model 3, and for the manufacturer, we choose the Tesla, and the price estimate around 1,081 ringgit to 2,042 ringgit for the Malaysian market. Alright, so for the last one is product specification and dimension. For the dimension, which is length 1,220 millimeter, and for the width 1,848 millimeter, and for the height 1,441 millimeter. Alright, so for the next is a direct coefficient, what we call this the CD. Alright, so 0.219, which is highly optimized to prevent early for what called it separation. Alright, so for the last one is aerodynamics element, which is the features a grill-less nose and cone, and flat underbody panels to ensure a smooth external airflow of the working fluid, which is the air. So that's all for me, and I will pass for my member group, which is the Sophia, for explain the mechanism. Alright, so thank you.
First, let's take a look on how Tesla Model 3 works. Unlike conventional cars that use gasoline or diesel, the Tesla Model 3 uses electrical energy stored in a lithium-ion battery pack. The battery supplies electricity to an electric motor. Then the motor will convert electrical energy into mechanical energy, which rotates the wheels and moves the vehicles. Next, we will discuss the working fluids used in the Tesla Model 3. Although it does not use fuel as a working fluid, it still requires several fluids, such as coolant fluid for the battery temperature control, refrigerant for the air conditioning and heat pump system, brake fluid for the hydraulic braking system, and windshield washer fluid. Now, let's discuss the principles and laws involved. The Tesla Model 3 operates based on electromagnetic induction. Electric current flowing through the motor creates a magnetic field and producing rotational motion. It also follows Newton's second law, which is F equals to ma, where force equals to mass and multiplied by acceleration. In addition, the law of conservation of energy applies because electrical energy from the battery is converted into mechanical energy to drive the vehicle. Next, let's move on to the Mach number. Mach number is the ratio between the vehicle speed and the speed of sound. The formula is m equals to v over a, where v is velocity and a is the speed of sound. For example, when the Tesla Model 3 travels at 100 km per hour, the Mach number is approximately 0.08. Since the value is less than 0.3, air compressibility effects can be Now, let's talk about friction. Friction occurs between the tires and the road surface inside wheel bearings, brake components, and also due to air resistance acting against the vehicle. The aerodynamic drag force can be calculated using the formula where P is air density, CD is drag coefficient, A is frontal area, and V is velocity. Tesla Model 3 has a low drag coefficient of approximately 0.23, which improves efficiency and driving range. Next is the Reynolds number. The Reynolds number determines whether fluid flow is laminar or turbulent. The formula is Re equals to PVL over mu. Using the Tesla Model 3 dimensions and operating speed, the Reynolds number is approximately 8.8 multiplied by 10 power of 6. This value is much greater than 4000, indicating that the airflow around the vehicle is turbulent. For laminar or turbulent flow analysis, we can also use the fluid number. The formula is Fr equals to V over GL square root. The calculated fluid number for the Tesla Model 3 is approximately 4.1. This indicates that inertial force dominates over gravitational force during vehicle motion. Combined with the high Reynolds number, the airflow around the vehicle is classified as turbulent. Finally, here are list some of the important formulas that are related to the Tesla Model 3 mechanism, such as Newton's second law, kinetic energy, electric power, aerodynamic drag force, Reynolds number, Mach number, and fluid number.
Now I would like to talk about problems encountered in external flow application for vehicles. The first problem is high aerodynamic drag. This problem occurs during the highway or high-speed driving. It happens because air resistance as the vehicle moves faster, causing more drag and reducing fuel efficiency. The second problem is turbulence behind the vehicles. This occurs at the rear of the vehicles. It happens because the airflow separates from the vehicles, creating a low pressure wake that increases aerodynamic drag. The third problem is crosswind instability. This occurs on the side of the vehicles, especially when driving on the open road or bridge. It happens because strong crosswind disturbs the airflow around the vehicle, making it less stable and harder to control.
This slide shows several suggestions for improving the aerodynamic performance of the vehicle. First, we can install an active rear spoiler. An active rear spoiler automatically deploys when the vehicle reaches a high speed. This helps improve airflow over the rear section of the car and reduce flow separation. As a result, aerodynamic drag is reduced, vehicle stability is improved, and energy efficiency can be increased. Second, we can improve a wheel aerodynamic. The rotating wheel creates turbulence, which contributes significantly to aerodynamic drag. By using aerodynamic wheel cover and air curtain system, the airflow can move more smoothly around the wheels. This helps reduce air resistance and improve the overall aerodynamic performance of the vehicle. Third, we can optimize the rear body shape. The turbulent wake is mainly formed at the rear bumper and trunk area due to airflow separation. By designing a smoother rear profile and adding a diffuser, the airflow can remain attached for a longer distance. This reduces pressure drag and improves the vehicle efficiency. In conclusion, these three improvements can help reduce aerodynamic drag, improve vehicle stability, and increase the overall energy efficiency. Thank you for your attention.
Hai, Assalamualaikum warahmatullahi wabarakatuh. My name is Nurul Ali Akila binti Nur Nizam. I'm going to continue this presentation. To conclude, the Tesla Model 3 shows how fluid mechanics is applied to vehicle design. The airflow around the car is turbulent, and the low Mach number means the airflow can be treated as incompressible. So, in our analysis, we identify many issues. So, I'm going to talk about airflow separation at the rear and turbulence around the wheels, both of which increase drag. So, to improve the performance of the car, we suggest using an active rear spoiler and aerodynamic wheel cover to reduce drag, improve stability, and increase energy efficiency. Overall, Tesla Model 3 has a highly aerodynamic design, demonstrating the importance of fluid mechanics in modern vehicle. That's all from our group. Thank you so much.